Assalamualaikum everyone. Yes, I am doing a different type of video because now we're in the type of chemistry where writing it on a board is going to be extremely hard. Don't worry if you're missing the board. I'm going to use the board for any type of mathematics needed in these videos. Anyways, now today we are going to talk about kinetics. Now let's say, for example, you have some molecule and you're going to react to it with another molecule, but you have to make sure that molecule has to hit the molecule you are targeting. Let's say something like carbon dioxide, and you have two hydrogen gases. You want it to hit the oxygen side. If you're hitting it in the carbon side, you won't get any water anytime soon. Just like those car games some of my friends talk about, you have to hit it just right in the exact position. Now, the study of rates of the reaction is called kinetics. Now, just like I said, there is going to be some level of inaccuracies with where it is hitting, but there will be the time where it will hit just right. There are other many ways that a reaction can happen in a snap of a finger, and the other reaction can happen within 1 day or so. Now, rate equals to m by s, or molarities per second. Let's say we have 2N2O5 and it's going to be 4 nitrogen dioxide and a simple oxygen gas. We can discuss the rate as the change in concentration of each product by changing in time. Now, this obeys stoichiometry. So one oxygen will appear every 4 nitrogen dioxide. So oxygen appears 1/4 the rate of nitrogen dioxide, and 1/2 the rate N2O5 disappears. Now we can measure the rates of the reaction in many ways, but any method will include the concentration of the substance. We can use a manometer, a spectrophotometer, I believe that's what it's called, and we can plot the data with concentration versus time, and we can calculate the tangent line and the equivalence, which is actually better than finding out the average, which will be less accurate than this one. Now let's say we have a reaction, A plus B will be C. The relationship between the rate and the concentration is the rate order. Let's say in trial 1 we have some concentration and the rate is the same. And now let's say we did another trial and doubling the concentration doubled the rate. We call that first order with respect to A. Now let's say the doubling the concentration quadruples the rate. We call it second order to A. If the rate doesn't affect at all, no matter how much concentration you give it, then it's zero order with respect to A, and so on and so forth. Now, the overall order of a reaction is the order with respect to A plus the order with respect to B. Now, the rate law is K times the concentration of one substance raised to another power, and times concentration of another substance raised to some power. Now you're saying, what power should we raise it to? Now, the power should be raised to the order with respect to that substance, and that power won't be related to the coefficient of that substance. And if it happens, it's just a coincidence. Now I see you asking how to experimentally determine the order of a reaction. Using initial rates data, we can run several trials and vary the initial concentration of one reactant at a time. Now let's go on the board for more information, because this will be hard to edit. Now, as I've said, we can run several trials and vary the initial concentration of one reactant at one time. So let's say we have this reaction up the top. These are the concentrations. Let's say on trial 1 we keep all 1 moles, and this is the rate. Now let's say we double one of the concentrations. Then let's say if it were to quadruple, then we say it's the second order. Now let's say on another trial we increase the concentration of the other concentration, and we see that this is third order with respect to nitrogen monoxide. And so we can do some extremely simple maths and figure out that this is a fourth order reaction overall. Now in the rate law, K is the rate constant, and there will be many units of K. Like for a 0 overall order reaction, there will be unit of m divided by s, or molarities per second. In 1 order overall reaction, the unit will be inverse second, or 1 by time, the unit of time. 2 will be m times s, all inversed to the 1 power, or the inverse of m times s, or 1 over m times s. Now let's say we used our previous example to use the units, or what the unit will be of one reaction. Now keep this in mind, but in a fourth overall reaction, this is the unit. So if we raised it into the power of 3 and applied the distributive property, we would get molarity raised to the 5th power minus 3 molarity to the 4th power, unit of time, and molarity minus molarity cubed. This is actually what I got. If you got something different, please let me know down in the comment section below. Now let's say you are trying to find how to find the concentration at any given time. Now to do that, I'm giving this as an example, and luckily for us, this can be plugged into a y equals to mx plus b graph. If you want to know how, check out my algebra video about y equals to mx plus b, link up in the cards. Basically, there's a y, there's an m, there's an x, and there's a b. And the x will always be the time. So that's all there is to it. Thank you for watching. If you want more videos about math and science, make sure to subscribe, leave a like down below, and ring the notification bell if you want to be notified every time I make a video. And thank you for watching, and I will see you next time. Bye!